What happens when you turn on a light or start a load of laundry? Power, energy, comes to your community from a large central source. Every time you plug something in, turn something on, or power up, the demand on the power plant increases. And when an entire community is using a lot of energy, demand grows to a peak. The higher use periods for energy are mostly earlier in the morning and mid-afternoon to early evening. These are called peak load times, or peaks. These peaks increase energy costs for everyone and increase the strain on our energy infrastructure. Think of our energy distribution system as being like a highway. Everything has to be built to accommodate peak usage times, like rush hour. This makes energy distribution and production costly and less efficient. But what if there was another way? The RDSI, Renewable and Distributed Systems Integration Project, sought to address this question through a cooperative study supported by the Department of Energy and local matching contributions. These partners wanted to demonstrate if there was a different way for us to generate energy and consume energy that's better for our environment, infrastructure, and our wallets. So in 2009, project implementation began, and 2 years later, the demonstration was done. Using 2 circuits from the Linden Tech substation and distributed energy sources within the original FortZed boundary, the RDSI project studied how electric peak could be managed with a combination of renewable and distributed system resources. Peak shaving is reducing peak energy demand or loads. This was done by the combination of turning things off and producing energy on a distributed system, with the result of reducing the strain on the electric system. Spray integrated new monitoring and control technologies in the partner sites, like the CSU Engines Lab, New Belgium Brewing Company, Colorado State University, and Larimer County buildings. These new technologies enabled the integrated operation and control of distributed energy sources like solar panels, natural gas turbines, and generators to reduce peak load and related strain on the power distribution system. The new technology could also turn off energy-consuming devices as available to also help reduce peak load. So, to reduce peak loads, RDSI turned off things that weren't in use and took advantage of other distributed energy sources to meet demand. It sounds easy, but it's actually very, very difficult. There were some issues along the way. But at the end of the project, the initiative achieved its goal of reducing peak loads by 5 megawatts, enough to power 1,500 homes on a summer afternoon. The Fort Collins RDSI collaboration completed the project on time and on budget. But that was only Phase 1. Phase 2 was a more concentrated effort to demonstrate a microgrid in action. Working together, the FortZed partners leveraged infrastructure to connect the Northside Aslan Center to the CSU Powerhouse Engines Lab to make a utility island. Using solar energy sources at Aslan and generator sources from the powerhouse, the project used existing technology to demonstrate that a microgrid working across the Fort Collins distribution system with remote sites could work. This project had a number of challenges, but it paved the way for a greater understanding of how to successfully integrate solar energy sources into a microgrid and how to manage demand response on a microgrid. We've learned what to expect from our energy infrastructure, how to integrate distributed sources successfully, and how our environment is affected by some of our energy sources. Knowing this, we can move forward with advancing the technology and behavior that guides how we use and conserve energy in Fort Collins. This project was made possible by the FortZed site partners, the generosity of these funding partners, and the following technology partners and providers: